forth. So thanks a lot for sharing that. We are going to shift now from the DC area across the Atlantic to Paris, where we have Mohamed waiting in the wings for us. So Barry, thank you so much. We'll look for you on Slack. Mohamed, we're ready to kick off with you. I was chatting with Mohamed in the Slack channel, and I said, "Where's the jealous emoji?" Because I would love to be in Paris, with him. So Mohamed, let's just do a quick sound check with you to make sure we can hear you. Yep. Okay. We have sound, so that's good. And Mohamed is going to talk about deploying a CI/CD pipeline as infrastructure as code into AWS. He's going to talk about managing Docker images within Nexus as a Docker registry. So I'm really looking forward to this. And without further ado, I'll let you go. Why don't you share your slides? I'll tell you if you can. We can see them.
Yep. Can you confirm that you can see my slides?
Right now, I'm seeing you.
Wait a second. Yep.
Now I'm seeing your desktop. Now I see your slides. Perfect.
So hi, everyone. Welcome to Nexus User Conference again. I hope you are enjoying so far. So I'm Mohamed. I'm a software engineer living in Paris. I have been working with containers and serverless for the past 4 years. And today I'm going to talk to you about CI/CD and how you can use concepts like infrastructure as code, automation, serverless, and containers to build your own CI/CD platform in AWS from scratch. So the platform we're going to build today is what you can see on this following diagram. So I'm going to build a Jenkins cluster with a dedicated Jenkins master and a couple of workers. The workers will be responsible of building our application onto a Docker image, and then storing this image to a Docker-hosted repository on a Nexus server, and finally deploy this application to a Docker Swarm cluster. So as you can see, my Jenkins workers will be inside an auto-scaling group, and to define the auto-scaling policies, I'm going to create a CloudWatch alarms that will trigger a scale-out or a scaling event. So for example, if the CPU utilization of my Jenkins cluster is higher than 80%, that will trigger a scale-out event to add a new Jenkins worker to the cluster. And the same concept will be applied over my Docker Swarm cluster, with the difference of having 2 layers of scaling, a scaling at the instance level and a scaling at the container level. So for the scaling at the instance level, it will be easier as we will use the CPU utilization of our Swarm cluster. But for the scaling at the container level will be quite tricky, as we need to push some custom metric to our monitoring system. And this metric generally it's a business metric. So for example, the metric will be number of messages waiting in the queue to be processed by our container. So if this metric crosses a certain threshold that we will define, that will trigger a Lambda function, which will use the Docker API to add more replicas of our container. So as you can see, this is a good example of how you can use serverless with containers while deploying your application. And finally, to have a global overview of what's going on this CI platform, we're going to configure Jenkins to send us notification to our Slack channel every time there is a new build or a release available for production. And we do the same also for our CloudWatch monitoring system to publish a message to SNS topic to send us an email notification every time a scale out or a scaling event has occurred. So as you can see, this is what we're going to build on the upcoming 25 minutes. So I'm going to do a live coding demo today. So if things goes horribly wrong, you will be highly entertained. So wish me good luck, and let's get started. So what I'm going to do first is I'm going to create the CI platform that I just showed you on the diagram. And to do so, I'm going to use Terraform. So Terraform is an infrastructure as code tool that allows you to describe your entire infrastructure and templates file, and then it will read these templates file and transform them to API calls. So what I did here in advance, I created template file for each component of my CI platform. So here I have a template file to create a Jenkins master, which will be a simple EC2 instance. I have another one for my Jenkins cluster, which will be inside an auto-scaling group with a minimum of 3 workers. And to add and remove my workers automatically, I have defined a CloudWatch metric alarm, which will be based on the CPU utilization. So here, if the CPU utilization is greater than 80%, that will trigger a scale-out event to add an instance to the cluster. And if the CPU utilization is less than 20%, that will trigger a scaling event to remove an instance from the cluster. And finally, for my Docker-hosted repository, it will be on Nexus server running on an EC2 instance. So this is guys, the templates file that I'm gonna use to create this platform. So let me go back to the terminal and let's create the platform. So on the terminal, I'm gonna run Terraform apply command, and I will give it as a parameter my variables files on which I have defined my AWS credential and the VPC on which I want to create the stack. So I already created a VPC in advance with 2 private and 2 public subnets, and also I have created a jump box which I will use to connect to SSH to my instances on the private subnet. So here, as you can see, Terraform created what we call an execution plan. We show you things that will be created in advance. Once you are happy with these changes, you can apply them by typing yes, and then Terraform will create the CI in AWS. So it will take a few seconds to create the stack. And meanwhile, I'm gonna back to my slides and I'm gonna show you a new concept that you can use while building your CI platform. So if you worked with Docker before, you should be familiar with this concept, as every time you change your source code or you add a new feature to a microservice, you have to build a new Docker image. So you always start from a new resource, which allows you to do code promotion, blue-green deployment, and rollbacks if things goes wrong. So this is what we call immutable infrastructure. And this concept can be applied also when you are managing and creating your infrastructure machine images. And one of the tools that allows you to do that is Packer. So Packer basically will take template files on which you describe your custom machine image, and then it will create a temporary instance from a base image. And by using configuration management tools like Ansible, Chef, Puppet, Salt, or whatever tool you are familiar with, you can provision the temporary instance and install all the necessary software and packages and security patches. And then Packer will bake a new AMI and create what we call a gold image with your software pre-configured and ready to use. So what I did here for this demo, I have created an AMI for each component of my stack. So as you can see here, and to save time, I'm gonna show you how I created the AMI for the Nexus server. So let me go back to the source code. And here I have a Packer folder on which I have a folder for each AMI for my platform. So for the Nexus AMI, I have created a template file, which is simply a JSON file. And here for the base image, I have used the official Amazon Linux image. And to provision the instance, I have used a simple shell script, which simply will install the Nexus OSS version following their official documentation. Here it's starting the service, and here it's waiting for the server to be up and running. And finally, it's used Nexus great feature, which is its API. So by using the Nexus API, you can post some Groovy scripts to automate and to customize your Nexus. So what I did here, I'm posting a Groovy script to the Nexus endpoint, and this Groovy script will just simply create a Docker-hosted repository on Nexus with the name of Nexus-user-conference. So as you can see, by doing that, I will create a gold image with Nexus pre-installed, and moreover, with the same template file that I just showed you seconds ago, I can create a Nexus machine image for different providers. So I can create a Docker image with Nexus. I can create a Google Cloud Engine with a Nexus pre-installed. So by now, I think Terraform should be finished creating the stack. So if I go back to the terminal, I will have an output section on which Terraform will display the URL access to each component of our CI platform. So what I'm gonna do here, I'm gonna copy the Jenkins URL. And if I point my browser to this link, I hopefully should see the Jenkins dashboard. And as you can see, my Jenkins is running. And if I refresh this, my 3 workers had joined the cluster automatically. So if you were wondering how I made my Jenkins workers join the cluster automatically, the answer is by using a simple shell script. So on my Terraform template files, especially for the autoscaling group for my Jenkins slaves, I have given them a shell script which will be executed at the boot time. So when my Terraform will create the workers, this shell script will be executed, and it simply fetch the private IP of the instance from the EC2 metadata, and then here it's using the Jenkins master API to post a Groovy script with the private IP address to make the node join the cluster automatically. So as you can see, this is how you can use infrastructure as code, immutable infrastructure, and automation to create a ready-to-use Jenkins cluster with all the necessary plugins, configuration files, and plugins. So now we verify that our build server is running. Let's see if our Docker hosted repository has been created. So I'm gonna back to the terminal and I'm gonna copy the Nexus URL. And once again, if I go to this URL, I should have the Nexus repository manager interface. So it's still loading. And if I click on browse, I will have my Nexus User Conference, which is a Docker hosted repository. And if I click on it, it should be empty. So now our stack is deployed. We can create and write our first continuous integration pipeline. And to do so, I have created an application in advance. This application I have implemented in Golang. So it will simply serve a simple HTML page. And because I wrote my application in Golang and my Docker file, I have used a multi-stage feature build to build a lightweight image. So here in the first stage, I'm compiling and I'm building my application to have a single binary. And on the second stage, I'm just copying over the binary to an Alpine image. So I will end up with a lightweight image of around 5 megabytes. And finally, I have created a Jenkins file on which I have described the CI steps. So here, this pipeline will be running on the slaves, and the steps will be checking out the code and running some unit tests from a Docker container. So here I will create a Docker container based on this dockerfile.test file, and as an entry point, it will execute the go test command to run my unit test. And on the third stage, I'm building my Docker image from this Docker file. And finally, I'm pushing this image to the Nexus private registry. So now let's go back to Jenkins and let's create our first job. So on the Nexus dashboard, I will create a new item and I will call it Nexus User Conference -application, and it will be a multi-branch pipeline. Now, if I click on OK, it will take a few seconds to create the configuration file. And then we need to specify the code repository in which my code is stored. So I already created a GitHub repository. And for the credential part are already created because I used Baker. So while creating the AMI for Nexus for Jenkins master, I have created also my default GitHub credential on Jenkins. And for the owner, I will set my username. And then I will specify the repository in which my code is stored. So it will be Nexus User Conference -application. And for the behavior part, I will let Jenkins scan all the branches looking for a Jenkins file. Now, if I save, the pipeline will be executed on the master branch, as you can see here. And my pipeline will be executed. So the first stage will be checking out the code, and then it will run the unit test. So as you can see right now, it's running the unit test. So it will take a few seconds because the first time my Jenkins workers doesn't have the Golang image. So they have to pull it from Docker Hub, but afterward it will be faster. So if we click on the logs, we should see that our worker is pulling the Golang image from Docker Hub. So it's still pulling the image. And I think by now the test stage would be finished. So if we click on it, we should see that our unit test has been successfully passed, and then it will start building the Docker image. So I think the build stage will be faster because we already have the base image, the Golang base image. So as you can see, the build stage has been finished, and now it will push the image to the Nexus private registry. So now our pipeline has finished. So let's go back to the Nexus repository manager and let's see if our image has been stored. So if I refresh this page, I should have my new artifact, which is my Docker image stored on the Nexus repository with the latest tag and another tag which represent the commit ID. So this is, guys, how you can do continuous integration. Now let's deploy our application and let's do continuous delivery. But first, we need to create a deployment environment. So the deployment environment will be a Swarm cluster. And to do so, I'm going to use Terraform. So similarly to the pipeline and to the VPC, I'm going to use the Terraform to create my Swarm cluster. So I'm going to go back to my infrastructure project. Here I have a Swarm folder, and on this folder I have specified my templates file, which I will use it to create my Swarm cluster. So I will have an auto-scaling group for my Swarm manager. So I will have a tree managers, and I will have another auto-scaling group for my Swarm workers, which will be responsible of running our containers. And as a minimum, I will start with 5 workers, and to add and remove workers and manager automatically. Similarly, I have defined auto-scaling policies based on the CPU utilization. So now our templates file are defined. Just before we run the Terraform apply, I just need to change the variables files to set the Jenkins security group ID. So if you were wondering why I need to set the Jenkins security group ID, it's because Jenkins will need to SSH to our Swarm cluster to deploy the container. So on the security group of my Swarm cluster, I have to allow inbound traffic on SSH ports only from the Bastion host and also from the Jenkins security group. And to get this ID, you can either go to AWS Management Console and look for the security group dashboard, or you can use Terraform output command, which we'll be using in a few seconds. So here on the terminal, if I run Terraform output command, Terraform will use its state file and it will fetch the Jenkins security group ID. So as you can see, here I have the security group ID value. So I'm going to copy this value and paste it on this file. So now our variables are defined. Let's go back to the terminal and let's create our Swarm cluster. So once again, I'm going to run Terraform apply, and I will give it as a parameter my variables files. And then Jenkins will generate an execution plan that shows you all the changes that will be applied. So I will confirm that by typing yes, and then Jenkins will start creating the Swarm cluster. So while it's creating the Swarm cluster, I will show you another concept that you can use, which is cluster discovery. So if you use a Docker Swarm before, or you created a Docker Swarm cluster before, you should know that you need to do 2 steps, which are initializing the cluster and then making the workers and other managers join the cluster. And to automate this process, I have used a shell script which will be executed on both my manager and my workers at the first time they are created. So here, for example, the first machine that will be created by Terraform will run this script, and it will run the command docker swarm init command to initialize the cluster, and then it will take the token that has been generated and will save it on an S3 bucket. So other manager and other workers can fetch this token from the S3 bucket, and then they can join the cluster automatically. So for this example, to keep it simple, I have used S3 bucket for the service discovery, but you are free to use any distributed key value storage like etcd or console. And by the way, I'm just looking forward to have this feature on Nexus. So I would like to have Nexus. I would like to use Nexus as a backend for my Swarm discovery also. So I think by now, Terraform is still creating the stack. So while it's creating the stack, I'm going to show you the S3 bucket that I'm using for the Swarm discovery. So here on the S3 Management Console, if I refresh this page, I should have a folder which was created by the first manager or the first node that was created by Terraform. And this node will store the tokens on this file, and then it will register its IP address to this bucket. So now all the nodes that will join the cluster will register their IP address on this S3 bucket. So if I refresh this, as you can see, my 5 workers have joined the cluster and they register their IP address. So I think now Terraform should be done, and it will display a URL, which is a dashboard that I have deployed on the manager leader, which I will be using to show you the global state of my Swarm cluster. So as you can see here, I have 3 managers and 5 workers, and the manager who is the leader is running the dashboard. So now our deployment environment is ready. Let's deploy our application. And to do so, we will create a new job on Jenkins. But before, I have prepared a Jenkins file in advance, and this Jenkins file will be executed on the master node, and it will SSH to the Swarm cluster, and then it will run the Docker stack command with a Docker compose file. And this Docker compose file will create a container based on the image that we just created earlier, and then it will expose the port 3000, which is the port my application is listening on. And on the deploy section, I have told the Swarm manager to deploy this application on this container only on the workers and to maintain one single replica. So before I create a job on Jenkins, I'm gonna just fix the manager IP to the new IP address. So here it will be 0.0.0.179, and then I'm gonna back to the terminal and I'm gonna commit these changes, manager IP, and then I will push these changes to the master branch. So now our changes are on GitHub. Let's create a new project to do continuous delivery. So on Jenkins, I'm gonna create a new item, which will be Nexus User Conference -deployment. So it will be also a multi-branch pipeline. And to save time, I will be using Nexus User Conference application. Now, if I click on it, I need just to update the repository name to be deployment repository. And if I save it, my master branch will be executed and my new container will be deployed. So if I go back to the dashboard, as you can see, my new container is now deployed on the workers. So now to test this application, I'm gonna create a public load balancer as our cluster is deployed on a private subnet. So there is no way to access this application from the internet without using a VPN connection or a Bastion host. So to make it simple, I'm just gonna create a load balancer, and to do so, I'm gonna use Terraform. So it will be also a good example for you guys to see how you can apply changes to an existing infrastructure. So here I'm gonna just do some copy and paste, and I will create a load balancer, which I will be called demo, and it will be on the public subnet, and it will be listening on the 3000 port of my application. And for the health check part, it will just do TCP health check on port 3000. Then I will need to create a security group for my load balancer. So once again, I'm gonna do some copy and paste. I'm just gonna fix the name, my load balancer, and then I need to allow unbound traffic on my Swarm cluster on port 3000 only from my new load balancer. And finally, I'm gonna assign this load balancer to the auto-scaling group of my Swarm workers. So I'm gonna use the load balancer's attribute, and let me just fetch the name. And then I will create a new DNS record on Route 53 to have a user-friendly URL to access to my application. And I will Terraform displayed its URL at the end of the creation process. So I should be fine by now. So if I go to the terminal and I run again Terraform apply, so Terraform will detect the changes and it will ask us if we want to create a new load balancer and if we want to update the security group of my Swarm cluster. So I'm gonna type yes, and then it will create the load balancer. So let me jump back to the AWS Management Console and show you the results sections. I will have my new load balancer, which is this one. So Terraform didn't add the instances yet, so it will take a few seconds for that. And as you can see now, my instances are on out of service because the load balancer didn't finish yet the health check. So while it's doing the health check, you might be wondering why I assigned the load balancer to the entire cluster instead of assigning it only to the instance on which my application is running. The answer is Docker routine match. So when you are working with Docker Swarm, all your Docker nodes are on a gossip network. So all the incoming requests to the cluster will be eventually get a response because the machines are capable of forwarding your request to the target application by using the routine match feature of Docker Swarm. So that's been said, if we read this page, so they're doing the check, and I think Terraform finished the creation process. So let's give it a few seconds. And as you can see, now they are in unserved state. So now if I go back to the terminal and copy this URL, I should be able to access my application. So let's give it a few seconds to make the DNS finalize. And as you can see, if I click on this, so as you can see, our application has been deployed, and this is how you can do continuous integration and continuous delivery. And finally, I'm just gonna show you how you can do continuous deployment. It will be straightforward, as I just need to update the Jenkins file that on my application repository to trigger a deploy process at the end of my CI pipeline. So I'm gonna just trigger the downstream job that we created on Jenkins. And to show you that this is a real demo and not a fake one, I'm just gonna add some text here. It's real. And we should be ready to go. So I'm just gonna commit these changes to GitHub. And then GitHub will notify Jenkins because I already created a webhook on the GitHub repository. So now all my changes will go through this Jenkins. All my changes will go through the pipeline. So as you can see, a new build has been started, and now it will be faster. So I think it will take a few seconds because I think the new build has been running on another workers. But let's just give it a few seconds, guys, and we should be finished. So it's still pulling the Docker image. Come on. And now it's building the Docker image. Come on, Jenkins. And as you can see now, the deployment process will be triggered, and Jenkins will SSH to the cluster and deploy the new container, which will be seen here. So let's refresh this page, and hopefully we will see our new release. So as you can see, guys, this is how you can do continuous integration, continuous deployments, and continuous delivery. So I showed you also how you can build your own CI/CD from scratch by using infrastructure as code, automation, serverless, and containers. So please join me on the Slack channel afterward if you have any questions. And see you hopefully next year. And thank you.
Mohammed, that was awesome. You ran the gauntlet of live demo and survived. So that was terrific. I had my fingers crossed the whole way. So it was awesome how smooth it was and well practiced. So Mohammed's going to jump on Slack if you guys have any questions. Is there a blog to reference on this, or a Git maybe a repository?
Yeah, sure. I will post on the Slack channel the GitHub repository that I used it through this demo. So you will find all the source code that I've used it. You will also find some useful Groovy script that you can use to automate and configure Nexus. So I will post everything on the Slack channel.
Awesome. That's super. Thank you so much.
Thank you so much. And thanks again for having me, guys.
Yeah, no, that was terrific.